So good morning to everyone, and thank you for coming. I hope my presentation will be useful for you and at least inspiring. I will start with a presentation of myself. I'm Maria. I studied in Russia and in Oslo mathematical models in economics, and then I took PhD studies also at BI, also in Oslo, and my research was about dynamics in modeling of customer satisfaction and loyalty. And since then, I was really interested in dynamics and especially in panel data. And so I see dynamical effects everywhere, and I hope to convince you that these effects are everywhere. And I hope you will enjoy this presentation. So let's just start. Moving. Yes. So let's start from the definitions. I wanted to distinguish between panel data and time series. If you talk about one individual over time, or one company over time, or one something over time, it's time series, and there are specific methods regarding modeling time series. But I wanted to focus on panel data this time. And panel data is defined by looking at many individuals over time. So it could look something like this. First, big table. So you see several people, 2 people in this example, over time, something changing like income. And we have some features of these people like gender, age, it can be occupation, anything else. And if we look at data like this, it's really tempting to include timestamp and tempting to see if it helps to find what we are trying to predict. And time reflects a lot of things, so it can be really useful if we can use it. Let's see how it works. So I love this topic because I see time effects everywhere, as I already mentioned, like unemployment changes over time, debt size changes over time, customer behavior, lots of things changing over time. And even if you don't think social studies, materials being worn over time, trees are growing. I mean, we observe changes with time everywhere. But I also hate this topic because time effects are everywhere. And the problem with that is that we need to predict something that we don't have in our training data set. So we need to find out like what is effect of time for our modeling problem. And why is it a problem? Why is it difficult? I like to show this picture. If we just observe some effect and we believe it's just there, we can extrapolate to really ridiculous conclusions. And if we work with a linear regression type of models, then we can just increase or decrease until infinity. And if it's like decision tree type things, we will end up with a last observation, last observed time point, or if time is a number, or it will be like other category if time is a string. So anyway, we will predict something which is not correct. So it is really difficult. It is really important, and sometimes it is difficult to understand what is time effects in your modeling issue. I have created an example which I will refer to during this presentation. We could consider housing loan payment. It's big and it's many payment over a long period, and usually data set looks something like this. So you have several customer IDs. 2 in this example. You have payment ID. Very often it is claimed to be stochastic, but you see that it's growing with time. You have payment size, which is changing. It can be constant for one person, or it can be different even for one person, and it's different between people. We have different payment date IDs. We have age, which can change also between years, but also within the year. It depends how we calculate this age. We have gender, which usually it is stable within the person, and we have income. Again, income may change dependently on how often we update our data set. We also have some loan starting information like age, address, number of kids, occupation, and these kind of things. And very usual problem setup for this question, for this data is to find out probability of next payment or size of next payment. And why this is not obvious? I mean, why can we expect that next payment is coming and it will be of the same size? Because lots of things may happen in time. Like here are some examples. So it can be changes in income, number of kids, other property and loan. It can be illness or willingness to pay may change. I don't know, debtor may be bored of paying his loan. Education may change, occupation may change. I mean, really lots of things which we don't observe. The only thing we observe is timestamp, and we just see, okay, something changes with time. So our first problem is to find out if there are any time effects, and second issue will be to model these time effects. So let's start with the first one, how to find and define time effects. And the first step here is to suspect them. So if you try to model these kind of things, just try to think first, what could that be? I mean, is it any processes or something dependent on time, so that time time stamp will look like influencing your process. And then try to experiment a little bit with different forms of time dependency. Like, for example, you can use, two things came at the same time, but both correct anyway. So you can use a year number and see if it is significant. In this example, it's linear regression just because it's easier to illustrate, but you can do it also with other types of the models. So you just include year and see if it works, if it looks significant. You can also include year in different forms like quadratic or linear or any other weird type of trend, just to see if there is something from timestamp that can influence your prediction. Also seasonality, if you know that people do something specific on Mondays, or if you know from experience that people tend to pay more when they get their vacation money, it's very wise to include this thing like week number, day number, or month number into your model and see if it helps. Also, you can use dummies and interactions with variables. Like in this example, I use dummy for 2003. And it means that it's 0 if it's 2000, it's 1 if it's 2003, and 0 in all other cases. And then if you see the thing significant, it means that something happened with X in 2003 that influenced Y. And then the question will be to investigate if it was stochastic change or stochastic happening, or if it was something something understandable that should be used in your modeling. Also, you can see, for example, that each 5th year in such setting is significant or something like that. And then it's wise to investigate it and to include it also if you found explanation. Another approach is to use time-related inputs, like if you use at GDP or consumer price index or bullion price index, something like that. We know that it changes with economical cycles. So it reflects economical decrease and economical growth. And if you can suspect that your process can be related to these economical changes, like if people tend to pay less in economical decrease or to pay more in economical increase, it can be wise also to test this kind of relationship. I also wanted to mention one method. I will not really focus on that. It's structural equation models and latent growth curves models. These methods are more scientific, I would say. They help us to find very specific relationship between time and your variables, like if it's related to specific variable, if it's related to specific coefficient, or if it's related to specific like log of your variables. These methods are very good in terms of research, but quite difficult to implement in like normal production. So if you're really interested to find out what is time relation in your modeling process, it's wise to use this method, but then you would have to think, okay, what I will do with this information. It's kind of difficult to implement after you found these effects. So after you have defined the effects and you have checked, okay, yeah, there is something about time in my model. So what we can do with that? First thing, I have marked it with theoretical because it's not really perfect, probably. is to delete all time-dependent variables. So you found out something related to time and you say, oh no, I don't want to look at the dynamics. I want to model only stable things. I want to look at willingness to pay based on gender and address, for example, or something more constant. And it can be okay if you decide to model stable things and dynamical things separately and then combine two models. So it's still the way to do. But I mean, deleting is not an option for this presentation, at least. So just remember that it's an option. If what practically we can do, there is a very good thing, but it's difficult to obtain very often. So if we could find some variables which capture time effects better than time, it's just perfect. If we could measure willingness to pay in each period, or if we could find some changes in income, number of kids, anything that influence our process from external data, it's great. You can just include this stuff into your model and also then check if time effect was eliminated by that. Also, we can use GDP or something else as indication of economical cycles. There are different variables that you can use. And again, you can test if time effect was eliminated by this measure. It's great if you can do that, but very often it doesn't help or you don't have enough information for doing this. So what else we could do? We could consider first differences, lags, and shares. Like if you want to predict willingness to pay based on how much income has changed from previous year, it's first difference, or how big income debtor had in previous period. So it's lag, and share of income in current period related to some base period. So it's what I mean by share. And why this could help? First of all, it's because we predict today by yesterday information, and then we can predict tomorrow having today's information. So we do have actually in our training data set what we want to predict. It's very practical and convenient. And also, like if you think about income, usually income is increasing. And so when we predict something for tomorrow, income may be bigger than you had in your training data set. But if you look at changes, probably you have had this size of changes already in the data set, and then model will work better. So it's a quite good option, and very often it helps. What else we could do? We could use trend lines. If we know from theory that specific form of trend reflects your process, it's wise just to use it as it is. So for example, we know from theory that probability to quit business relations is high in the beginning and after 10 years and low in between. So you can just use this U-shape in your model. Or if you know that some materials are getting worn with exponential growth, like it's the speed of getting worn is increasing with time, so you can just use it as it is. And also usually it's very helpful. I mean, if we already have theory about time relationship in this process, it's just you can just use it as we know from theory. Also, you could use periodical trends, and this topic is my favorite. This thing is my favorite. I really encourage you to try. And you could use trigonometrical functions as a trend line. I have special slide for that. It's not very scary, just some formulas, but very simple formulas. So if you decide to use trend as a periodical function, you could look at the formula from this first equation. And you see some coefficients inside sinus trigonometrical periodical function, where D1 shows displacement of sinus wave in relation to origin, so how far it moves, like when it starts, if it starts at 0 or if it starts somewhere. D2 is a period of sinus wave, so it's length. It's like, okay, how many years or months or days or something in between two minimum. And C is the size of sinus wave, like size of effect, so height of sinus wave. If you open brackets, you get probably easier formula with a combination of sinus and cosinus. And it could be difficult to estimate D1 in such setting in many packages. But even having D1 equals 1, you get this last equation. Really simple, I mean, like normal linear regression, but you can use these variables also in tree type models. you will have period of this function, then of this cycle is about 6 years, a little bit more than 6 years. But it actually is average length of economical cycle in Norway according to Organization of Economical Cooperation and Development. It's like 6-7 years according to that organization. So from my practice, usually it works, and it works quite well. It's not that all people believe in economical cycles, but if you can explain, many people believe. So if you can explain from some theory why you include it, and if it works, I really encourage you to try and to do that. I think modeling social processes, like social related processes, or customer behavior, banking, insurance, it's really, this format really helps, at least from my experience and from my projects. We are coming to the end of the presentation, and I had a little bit controversial point at my last slide. It can be also wise to see, is it really time effect, even if you observe change? Like if you look that the person have gotten education at some point of time, is it really change, or is it just confirmation of his ability to get education? Like he's just a clever person. And you can look like that to many other variables, also like income, for example. If person have income, maybe it's just his ability to get money, and it's not that important how much money he has. Or if person pays, maybe it's just his ability and willingness to pay, like pay in person, and no matter how often or how big payments are. And it doesn't fit to all model settings, of course, but sometimes it fits. And so it's also can be useful to experiment a little bit with this kind of thinking and to see, so maybe change that you observe is not really change, it's just new information, but nothing new to the process. Like if you, especially it's useful if you suddenly get more information at year 10 of your observation period, and okay, you don't know what to do with that, but it really depends on what kind of information is there and if you can treat them as a stable effects. Like if you're suddenly starting to observe gender, of course you see, well, yeah, gender, most probably it was the same in the beginning of my period. And so you can try to look like that in other variables as well. And so maybe it's not really time effects in your model, but some stable specific effects. So that's what's it from me. Thank you very much for your attention. I hope you got some inspiration from that. And if you have questions, just ask, or you can contact me also by email or via LinkedIn. And I really love to discuss these dynamical issues. So let's just talk about it. Thank you.